Hello students, welcome to our online lecture. This is our second lecture of amines. In last lecture, we have started chapter number 13, amines. In that, we have seen the introductory part of amines. Afterwards, we have seen the classification of amine and nomenclature of amines. And lastly, we have seen the methods of preparations of amines. Now, today we are going to discuss chemical properties of amines. So here, first chemical property of amine is alkylation of amines, or it is also called as the Hofmann's exhaustive alkylation. Alkylation of amines. The word itself gives its meaning. Alkylation, that means alkyl group introduction, right? And kiska amines, that means in case of amine, alkyl group is introduced or alkyl group is added. That is called as the alkylation of amine. So primary amines, that means RNH2, is undergo heating with excess of alkyl halide, gives a mixture of secondary, tertiary, and finally, and lastly, quaternary, or it is also called as the tetra-alkyl ammonium halide, is the final product, is obtained as a final product. Now this reaction is carried out in presence of mild base. Which mild base is used over here? The mild base is sodium bicarbonate. For what purpose it is used? It is used to neutralize HX, that means hydrogen halide, which is obtained as a side product, which is obtained as a byproduct during the whole reaction. Okay, and this reaction is very vigorous type of reaction. So that's why it is called as the exhaustive alkylation. And Hofmann's is the name of scientist. So that's why this reaction is called as the Hofmann's exhaustive alkylation reaction. Okay. Now, as you can see on the screen, see, firstly here, we have to take one primary amine compound, that means RNH2. Okay, now this is primary amine RNH2, which is reacts with alkyl halide. Because alkylation of amine, so that's why alkyl halide is the alkylating agent. Okay, so alkyl halide is reacts with primary amine. So excess of alkyl halide is used. So what happened here? Now this halogen atom and one of the hydrogen atom, it form hydrogen halide, that means HX, and this get removed from this reaction as a side product, and this R group is introduced over this nitrogen atom by replacing this hydrogen atom. So we get this R2NH. R2NH, that means two alkyl molecules or groups with nitrogen atom and with one hydrogen atom. So what is this? This is nothing but a secondary amine, right? That means from primary amine, we have to prepare secondary amine by replacing one hydrogen atom by alkyl group. Okay. Now similarly, this secondary amine is reacts with again second molecule of alkyl halide, because we have already taken excess of alkyl halide. Look here, we have already taken excess of alkyl halide. That means in our reaction mixture, there is a large amount of alkyl halide is present. Okay, so The secondary amine is reacts with next molecule of alkyl halide similarly, in a similar manner, like here. So in a similar manner, it is reacts with this alkyl halide by replacing this hydrogen atom. Alkyl group is introduced over this nitrogen atom, and this hydrogen atom combined with this halogen atom, and it removed in the form of hydrogen halide, in the form of HX, it gets removed, and we get finally as a trialkyl amine, right? That means this is tertiary amine, R3N, tertiary amine. Now in this case, there is no any hydrogen atom, but as we know, this nitrogen atom contains one lone pair. Because of this lone pair, it again easily reacts with this next molecule of alkyl halide. Okay, so again, this tertiary amine reacts with this alkyl halide molecule, and we get this final product, that means R4N positive X negative. Now, why this N is acquire positively charged? Because nitrogen loses its lone pair to form a bonding with alkyl group. So that's why it acquires positive charge, and halogen acquire negative charge, and hold this molecule called as tetraalkyl ammonium halide. What is the name of this final product? tetraalkyl ammonium halide. यहाँ पे ये HX नहीं चाहिए क्योंकि here nitrogen having no hydrogen atom. So how this HX is get removed? This takes place by mistake. So this happened by mistake. So here final product is tetraalkyl ammonium halide. Now this whole reaction is called as alkylation of amines or Hofmann's exhaustive alkylation. Now, take one example. Here, if excess of alkyl halide is used, tetraalkyl ammonium halide is obtained as a major product. Okay. Whenever excess of alkyl halide is used, tetraalkyl ammonium halide is obtained as a major product. Hence, this reaction is called as exhaustive alkylation of amines. Exhaustive alkylation of amines. Now, if we use methyl iodide as a alkyl halide, which reacts with methylamine. Okay, that means methylamine is our starting material, and it reacts with this methyl iodide. It undergoes heating. Excess of methyl iodide is used. What happens in this reaction? This one hydrogen atom is get replaced by this methyl group. So we get this dimethylamine with HI. Okay. Similarly, in next step, this dimethylamine, that means secondary amine, reacts with the next molecule of methyl iodide because methyl iodide is taken in an excess of amount. So formation of trimethylamine with HI, and finally this trimethylamine reacts with methyl iodide. We get tetramethyl ammonium iodide with HI. Now here in this reaction, HI is obtained as a side product, and this HI acts as a acidic in nature because this is hydrogen iodide. So this is acidic in nature. So to neutralize this acid, we have to use sodium bicarbonate as a weak base to neutralize this HI, which is obtained as a side product in whole reaction. Understood, student? This reaction is called as Hofmann's exhaustive alkylation reaction or alkylation of amines. Exhaustive alkylation of amines. Now this is the first chemical property of amine, which is very, very, very important. Again here, one more example. The This is ethylamine reacts with methyl chloride. We get this in first step. We get this N-methyl ethanamine. Again, this N-methyl ethanamine reacts with methyl chloride, formation of N-dimethyl ethanamine, and again it is reacts with next molecule of methyl chloride. We get this quaternary ammonium salt. Quaternary ammonium salt. Okay, this is another example of alkylation of amines reaction. Now the next chemical property is Hofmann's elimination reaction. Next chemical property is Hofmann's elimination reaction. Now again here Hofmann is the name of scientist. Okay. Here our starting material is the final product from previous reaction, previous chemical property, and previous chemical property is nothing but a exhaustive alkylation reaction. Here our starting material is tetraalkyl ammonium halide. Now this tetraalkyl ammonium halide is heated with moist silver oxide, which produce quaternary ammonium hydroxide. Now this is strongly basic in nature like NaOH and KOH. So that's why this hydroxide ion act as a base. Okay, and which abstract beta hydrogen atom from the reaction mixture, and it undergoes beta elimination reaction after heating. That means when quaternary ammonium hydroxide undergoes heating, it undergoes beta elimination to give an alkene. But here, alkene is obtained as a major product. But which type of alkene is obtained as a major product? The alkene which is least substituted in nature. Least substituted alkene is obtained as a major product, which is exactly contrast to Sedgwick elimination reaction. In Sedgwick elimination reaction, we have already seen in Sedgwick elimination reaction, our major product is obtained as a alkene. But which type of alkene is obtained as a major product in Sedgwick elimination reaction? The more substituted alkene is obtained as a major product in Sedgwick elimination. But in this reaction, a less substituted alkene is obtained as a major product. So this reaction is called as Hofmann's elimination reaction, which is exact contrast to Sedgwick elimination reaction. Now see the reactions. In first step, alkylation or methylation, exhaustive methylation takes place. Okay, so formation of the quaternary ammonium salt. Our product is quaternary ammonium salt. So we have taken here this amine. Now it is reacts with this methyl iodide. We get this quaternary ammonium compound. Now this quaternary ammonium compound is reacts with moist Ag2O. It is reacts with Ag2O. That means moist means ये क्या करेगा, ये आयोडाइड को निकाल के वहां पे OH ग्रुप अटैच हो जाएगा. So we get this product, that is hydroxide product, but this hydroxide is highly basic in nature. ये जो OH ग्रुप है यहाँ पे ये highly basic in nature रहता है और वो क्या करता है, with abstract, ये बल्कियर हो जाता है ना. So it abstract beta hydrogen atom easily and we get alkene. अब beta hydrogen atom कौन सा होगा, जो नाइट्रोजन एटम को अटैच डायरेक्ट कार्बन एटम कहेंगे, that is called as the alpha carbon atom. and next to the alpha is beta. So this is alpha, this carbon atom is alpha, and here this carbon atom is alpha, and this is also beta alpha. एंड नेक्स्ट कार्बन एटम से तीनों कार्बन के पास कोई नहीं है, बट ये वाले कार्बन के पास तीसरा नेक्स्ट है, दैट इज कॉल्ड एज बीटा. नाउ दिस बीटा हाइड्रोजन एटम इज एब्स्ट्रैक्टेड बाय दिस OH माइनस आयन. तो जैसे यहाँ पे एब्स्ट्रैक्ट होगा, नाउ कार्बन पे आएगा नेगेटिव चार्ज और वो डबल बॉन्ड फॉर्म करके ये नाइट्रोजन के साथ बॉन्डिंग ब्रेक डाउन हो जाएगी, एंड वी गेट दिस अल्कीन with this trimethyl amine. Now see here. Here less substituted alkene is obtained as a major product. This is less substituted alkene. एक ही साइड में इसका substituent है, ये भी methyl group. So that's why it is called as the less substituted alkene, which is the product of Hofmann's elimination reaction. See one more example. Here I have taken NN-triethyl propyl ammonium iodide. NN-triethyl मतलब 3 इथाइल ग्रुप्स होंगे और वो NNN है, दैट मीन्स N सब्स्टिट्यूटेड. नाइट्रोजन को डायरेक्टली अटैच होंगे 3 इथाइल ग्रुप, सो दैट्स व्हाई हियर NNN ट्राइइथाइल. प्रोपाइल अमोनियम मीन्स एक ग्रुप होगा प्रोपाइल, अमोनियम that means nitrogen पे positive charge, iodide means iron negative, which is reacts with Ag2O, moist Ag2O, so it produce AgOH, और वो AgOH कहाँ पे अटैच होगा, ये आयोडीन को हटा के वहाँ पे OH ग्रुप अटैच हो जाएगा. So we get this NNN triethyl propane ammonium hydroxide. Now this hydroxide is highly basic in nature with abstract beta hydrogen atom easily. Now here beta hydrogen atom कहाँ पे? So beta hydrogen atom कौन सा होगा? जो नाइट्रोजन को अटैच डायरेक्ट कार्बन रहते हैं वो अल्फा, ये वाला अल्फा है, तो इसके बाजू का है ये बीटा. ये वाला अल्फा है, तो इसके बाजू का ये बीटा है, राइट. ये वाला भी अल्फा है, तो इसके बाजू का ये बीटा है. और इन दिस रिएक्शन दिस इज अल्फा एंड दिस इज बीटा. But our major product is less substituted alkene. So अगर यहाँ से हाइड्रोजन आइटम एब्स्ट्रैक्ट होता है, ये वाला हाइड्रोजन, तो यहाँ पे डबल बॉन्ड तैयार होगा, राइट. और अगर ये ग्रुप से अगर हाइड्रोजन आइटम एब्स्ट्रैक्ट होते हैं फ्रॉम दिस कार्बन आइटम, हाइड्रोजन आइटम एब्स्ट्रैक्ट होते हैं, तो डबल बॉन्ड ऑब्टेन हियर. So which one is the less substituted alkene? This or this? This group forms less substituted alkene. So that's why our product is obtained as a ethene as a major product with NN diethyl propyl amine. With NN diethyl propyl amine. This is called as the Hofmann's elimination reaction. Now this is the mechanism of Hofmann's elimination reaction. So this is nothing but a amine which reacts with methyl iodide, produces this quaternary ammonium salt. In next step, quaternary ammonium salt reacts with Ag2O, which produce AgI as a PPT, and AgOH, which produce this species with OH minus ion. Now this species is treated with this OH, highly nucleic in nature, taps of this beta hydrogen atom, and we get this less substituted alkene as a major product. This is nothing but a Hofmann's elimination reaction. Now third one is reaction, chemical reaction is acylation of amines. What is the meaning of acylation? What is the meaning of acylation? Acylation number of times आप लोगों ने देखा होगा. Acylation, that means introduction of acyl group, and which is the acyl group? CH3CO, or in general RCO is the acyl group. Now acylation of amines, amines का अपने को acylation करना है. So Aliphatic or aromatic primary secondary amines that contain replaceable hydrogen atom on nitrogen atom or undergo acylation reaction. मीन्स ऐसे कौन से कंपोनेंट से कौन से अमाइन से जो एसाइलेशन रिएक्शन को प्रोसीड कर सकते हैं. द अमाइंस एलिफेटिक और एरोमेटिक कोई भी हो सकता है, बट कंडीशन शुड बी अप्लाई कि वो अमाइंस के पास ऑक्साइड रिप्लेसेबल हाइड्रोजन आइटम होना जरूरी है. अगर नहीं है तो ये रिएक्शन प्रोसीड नहीं होगी. तो रिप्लेसेबल हाइड्रोजन आइटम कौन से अमाइंस के पास रहते हैं? प्राइमरी एंड सेकेंडरी अमाइंस के पास रिप्लेसेबल हाइड्रोजन आइटम रहते हैं. टर्शियरी अमाइन के पास रिप्लेसेबल हाइड्रोजन आइटम नहीं रहते, सो दैट्स व्हाई टर्शियरी अमाइन डज नॉट गिव दिस एसाइलेशन रिएक्शन. ओके, दिस इज वेरी वेरी इंपॉर्टेंट टर्म. एग्जाम में भी आपको पूछा जा सकता है कि व्हाई tertiary amine does not give this acylation reaction and why primary and secondary amine gives this acylation reaction. What is the reason behind it? So you should know about that. Now, acylation is a nucleophilic substitution reaction in which amines reacts with acetyl chloride or acid anhydride, which produce amide. Now, this reaction is carried out in presence of strong base like pyridine to neutralize the acid. Pyridine is used as a strong base to neutralize the acid. Now, see the reaction here. Ethanamine is used as a starting material. Ethanamine का formula क्या है? C2H5NH2. NH2, that means primary amine. Okay. Now it is reacts with acetyl chloride. What is the formula of acetyl chloride? CH3COCl. Now this is simply nucleophilic reaction. So this is simply nucleophilic attack reaction. So nitrogen atom having a lone pair, one lone pair. So and this carbonyl group is the more electrode deficit group. So it easily attack on this carbonyl carbon atom. जैसे कार्बोनिल कार्बन एटम पे अटैक होता है, पाई बॉन्ड ब्रेक हो जाता है और इलेक्ट्रॉन्स ऑक्सीजन पे शिफ्ट हो जाते हैं, राइट. बट ऑक्सीजन आपका नेगेटिव चार्ज, और ऑक्सीजन नेगेटिव चार्ज के फॉर्म में ज़्यादा देर तक नहीं रह सकता है, तो वो क्या करेगा? खुद का नेगेटिव चार्ज शिफ्ट करेगा फिर से कार्बन के पास डबल बॉन्ड फॉर्म करने के लिए. जैसे वहाँ पे कार्बन और ऑक्सीजन के बीच में डबल बॉन्ड फॉर्म होता है, कार्बन की वैलेंसी हो जाती है 5, जो कि अनसेटिस्फाइड है, राइट. और नाइट्रोजन ने अपनी लोन पेयर लूज करके कार्बन कार्बन एटम पे अटैक किया, तो नाइट्रोजन पे आ गया पॉजिटिव चार्ज. ये दिख रहा है सबको यहाँ पे पॉजिटिव चार्ज, ये वाला पॉजिटिव चार्ज. तो नाइट्रोजन को एक बॉन्ड ब्रेक करना पड़ेगा टू गेन इट्स लोन पेयर. तो नाइट्रोजन ये हाइड्रोजन के साथ का बॉन्ड ब्रेक कर देता है. जैसे ब्रेक करता है, Cl एज अ बेटर लिविंग ग्रुप बाहर निकल जाता है एंड वी गेट दिस एन इथाइल इथेन अमाइड. Amide group formation takes place whenever amines reacts with acetyl chloride. Now here N-ethyl ethane amide is obtained. That means nitrogen को attach directly कौन है? ethyl group है, और 2 कार्बन एटम का इथेन अमाइड विथ HCl. तो ये जो HCl यहाँ पे तैयार हो रहा है, इसको न्यूट्रलाइज करने के लिए पायरिडीन एज अ बेस यूज किया जाता है. ओके. Now this is the primary amine. ये 1 degree amine था क्योंकि 2 हाइड्रोजन एटम है. If I use secondary amine, now this is 2 degree amine. 2 degree amine that means an ethyl ethane amine. नाइट्रोजन को अटैच एक इथाइल ग्रुप है और दूसरा इथेन अमाइन है, which is reacts with acetyl chloride in presence of base as a base pyridine. Similarly same यहाँ पे अटैक करेगा कार्बोनिल कार्बन एटम का. ऑक्सीजन यहाँ पे O नेगेटिव हो जाएगा, O नेगेटिव पॉसिबल नहीं, तो ये फिर से यहाँ पे बॉन्ड फॉर्म करेगा. हाइड्रोजन एटम बाहर चला जाएगा by giving electrons, और Cl भी यहाँ से बाहर चला जाएगा in the form of HCl. Final product is C2H5 and C2H5 C double bond O NH2. Now this group is amide group, NCO group is amide group. So formation of N-diethyl ethane amide is obtained with HCl. So this is the secondary amine. Okay, student. This is secondary amine. So now this is aliphatic secondary amine. If we use aromatic primary amine, same reaction, which is reacts with acetic anhydride or ethanoic anhydride. तो यहाँ पे क्या होगा, ये नाइट्रोजन एटम एक कार्बोनिल ग्रुप पे अटैक करेगा और ये बॉन्ड हो जाएगा ब्रेक, राइट, और ये हाइड्रोजन भी बाहर निकल जाएगा, वो इसके साथ अटैच होगा तो वी गेट दिस एसिटिक एसिड, और ये COCH ग्रुप किसको अटैच होगा, नाइट्रोजन को. सो फॉर्मेशन ऑफ एन फिनाइल इथेनामाइड और एसिटानोलाइड, N-phenyl ethanamide or acetanilide. This group is called as acetanilide. Now this is the acylation of amines. This reaction is known as acylation of amines. Acyl group is reacts with primary and secondary amine to produce amide linkage, to produce amide product. Next chemical property is carbylamine reaction. Next chemical reaction is carbylamine reaction. This is very important reaction. कार्बिलामाइन रिएक्शन सबसे ज़्यादा इम्पोर्टेंट है, मोस्ट ऑफ द टाइम ये एग्जाम में रहती है, क्योंकि दिस रिएक्शन इज वेरी यूजफुल रिएक्शन टू आइडेंटिफाइड प्राइमरी amines. Okay, so this reaction is qualitative reaction or qualitative test to identify the primary amines from secondary and tertiary amine. Aliphatic or aromatic primary amines which on heating with chloroform, carbylamine test, that means here our reagent is chloroform. Whenever foul और offensive smelling product तैयार होता है जिसको हम लोग बोलेंगे आइसोसाइनाइड और कार्बिलामाइन, on the basis of that smell we can say in this compound primary amine is present. That is the identification test. अगर कोई रिएक्शन में प्राइमरी अमाइन है और वो रिएक्ट करता है अपने क्लोरोफॉर्म के साथ, तो ये बहुत फॉल और ऑफेंसिव ऐसे डरावना स्मेल देता है, जिसके कारण हम लोग बोल सकते हैं कि यस, यहाँ पे आइसोसाइनेट कंपाउंड तैयार हो चुका है. और आइसोसाइनेट कब तैयार होगा, जब प्राइमरी अमाइन वहाँ पे प्रेजेंट होगा. ठीक है. सो प्राइमरी अमाइन, this reaction is used to qualitative test for primary amine. Primary amine के टेस्ट के लिए now this reaction is very important reaction. Now here primary amine, aliphatic or aromatic, you have to use anyone, reacts with chloroform, that means CHCl3 with KOH. Okay, CHCl3 with KOH, it gives isocyanate or carbylamine. It gives isocyanate, that means RN3 triple bond C with thrice KCl with thrice molecules of water gives isocyanate. This is the product isocyanate जिसको ये offensive smell है, false smell है. Similarly, if we use aromatic amine, which is similarly it undergo heating with chloroform with KOH, it produces carbylamine, that means isocyanate compound with 3 molecules of KCl and 3 molecules of water. This is the reaction of primary amine, aliphatic as well as aromatic with chloroform. See one more example here. Now primary amines reacts with the chloroform and the solution of KOH in ethanol to produce isocyanates. Produces isocyanate. Here methylamine reacts with chloroform with KOH, gives methyl isocyanate with KCl, 3 molecules of KCl and 3 molecules of water. Similarly, if we use ethylamine, which is reacts with chloroform, which produce ethyl isocyanate with 3 molecules of KCl plus 3 molecules of water. But here alcoholic solution of KOH is used. This is very important. Why isocyanate formation takes place? Because here alcoholic KOH is used, so that's why here isocyanate formation takes place. How isocyanate formation takes place, that we have seen, that we will see in the mechanism. Now see the mechanism. Mechanism is very important again. Now firstly, we have to take chloroform. What is the formula of chloroform? CHCl3. Chloroform का formula क्या है? CHCl3. Now firstly it is reacts with alcoholic KOH. Now if we use aqueous KOH, तो aqueous KOH act as a nucleophile. न्यूक्लियोफाइल मतलब क्या एक्ट होता है कि एक ग्रुप को रिप्लेस करके दूसरा ग्रुप वहाँ पे इंट्रोड्यूस हो जाना. दैट इज द रोल ऑफ न्यूक्लियोफाइल. बट हियर KOH इज यूज इन द फॉर्म ऑफ अल्कोहल. अल्कोहल के फॉर्म में वो यूज किया जा रहा है. सो दैट्स व्हाई उसका नेचर चेंज हो जाता है. वो न्यूक्लियोफाइल करके एक्ट नहीं होता, इट इज एक्ट एज अ बेस. और बेस का रोल क्या रहता है? हाइड्रोजन को एब्स्ट्रैक्ट करना. सो दिस इज एक्ट एज अ बेस, जो कि यहाँ पे ये एसिडिक हाइड्रोजन को एब्स्ट्रैक्ट कर देगा, and we get this CCl3 negative charge species. Now this CCl3 is negative, is very unstable species, right? So it removes Cl minus species and produces this dichlorocarbon. डाइक्लोरोकार्बन निकल चुका है, बट कार्बन, ये जो कार्बन है, दिस इज एक्ट एज ए इलेक्ट्रॉन डेफिशिएंट स्पीसीज. ना आप लोग बोले कि यहाँ पे तो दो इलेक्ट्रॉन दिख रहे हैं. हाउ इट इज एक्ट एज इलेक्ट्रॉन डेफिशिएंट? नाउ काउंट द नंबर ऑफ इलेक्ट्रॉन्स. कार्बन के पास कितने इलेक्ट्रॉन्स है? क्लोरीन के 2 बॉन्ड्स है तो इसके 4 इलेक्ट्रॉन्स, और ये 2 एक्स्ट्रा इलेक्ट्रॉन दिख रहे हैं, 6 इलेक्ट्रॉन. 6 इलेक्ट्रॉन, दैट मीन्स इनकम्प्लीट ऑक्टेट. सो दैट्स व्हाई इट इज एक्ट एज अ इलेक्ट्रोफाइल. Okay, and this species is called as dichlorocarbon, which is act as an intermediate species in this reaction. Now in next step amine की अब entry होती है. Amine react with carbene, dichlorocarbon. Now as we know, this dichlorocarbon is electron deficient and nitrogen atom from amine is electron rich. So it easily attack on this carbene, dichlorocarbon carbon atom. तो जैसे वहाँ पे अटैक होता है, what happen in this reaction? See, this nitrogen atom loses its lone pairs, it acquire positive charge, and carbon acquire negative charge with 2 chlorine atoms. Now this negatively charged carbon atom, and this is the hydrogen atom जो कि डायरेक्ट नाइट्रोजन को अटैच है और नाइट्रोजन पॉजिटिव चार्ज स्पीसीज है. तो नाइट्रोजन की टेंडेंसी होगी ना उसकी इलेक्ट्रॉन्स उसको वापस मिल जाए. तो ये जो हाइड्रोजन एटम है ये कहाँ पे चला जाता है? नेगेटिवली चार्ज कार्बन एटम के पास, बाय गिविंग द इलेक्ट्रॉन्स टू नाइट्रोजन एटम. तो नाइट्रोजन को इलेक्ट्रॉन्स अपनी लोन पेयर मिल जाती है और ये कार्बन को अटैच होता है हाइड्रोजन विद 2 Cl ग्रुप्स. बट नाइट्रोजन की लोन पेयर जैसे यहाँ पे आती है, नाइट्रोजन शांत नहीं बैठता है, वो बहुत उछल कूद करता है कि अब लोन पेयर है मेरे पास है, मैं फिर से यहाँ पे बॉन्ड फॉर्मेशन में इन्वॉल्व करता हूँ. तो जैसे यहाँ पे ये बॉन्ड फॉर्मेशन में इन्वॉल्व करता है, कार्बन के अटैच Cl है दैट इज क्लोरीन, इट इज एक्ट एज अ बेटर लिविंग ग्रुप, इट रिमूव इन द फॉर्म ऑफ Cl माइनस आयन, जो कि ये KCl के फॉर्म में बाहर निकल जाता है. ठीक है. Now this form we get this species here. Now again एंट्री होती है अल्कोहलिक KOH की. ये बचा हुआ हाइड्रोजन एटम जो नाइट्रोजन का अटैच है इसको भी ये खा लेता है, एंड वी गेट दिस डबल बॉन्डेड कंपाउंड हियर. बाय रिमूविंग दिस वाटर मॉलिक्यूल, डबल बॉन्डेड कंपाउंड यहाँ पे तैयार हो चुका है. नाउ हियर डबल बॉन्डेड नाइट्रोजन एटम नाइट्रोजन के पास तो लोन पेयर है क्योंकि ये हाइड्रोजन चला गया इन द फॉर्म ऑफ वाटर मॉलिक्यूल, तो नाइट्रोजन को अपनी लोन पेयर मिल गई है. जैसे उसके लोन पेयर मिलती है वो फिर से उछल कूद करता है और अपनी लोन पेयर यहाँ पे कार्बन के साथ बीच में यहाँ पे शेयर करता है इन द फॉर्म एंड फॉर्म ट्रिपल बॉन्ड. ट्रिपल बॉन्ड तो फॉर्म कर लिया बट नाइट्रोजन पे कौन सा चार्ज आएगा? पॉजिटिव. और ये कार्बन का जो अटैच क्लोरीन है इट इज अगेन रिमूव इन द फॉर्म ऑफ बेटर लिविंग ग्रुप एंड वी गेट दिस KCl. So final product obtained as a R and triple bond CH. Right. Now this hydrogen atom is abstracted by a base. अब base की entry तो होनी ही है, 3 बार KOH की reaction होती है. यहाँ से water molecule remove हो जाता है and we get this desired product as a RN triple bond C. RN positive, triple bond C negative. Okay. So this is the mechanism of carbylamine reaction. Understood student? I repeat one more time. In first step क्या होता है? This chloroform reacts with the alcoholic solution of KOH. It is act as a base. To abstract this acidic proton, we get his negatively charged carbon species. Then यहाँ से रिमूव हो जाता है Cl group, तो we get this dichlorocarbon. Dichlorocarbon reacts with amine, so a lone pair is there. Lone pair containing nitrogen atom attack on this dichlorocarbon atom, and we get this species. So then one by one addition of KOH means attack of KOH by abstracting hydrogen atom, and by removing the Cl group as a better leaving group, we get final product as a R N triple bond C. That means isocyanide as a better product. Okay, student. So this is the fourth chemical property. Now in next lecture we will see the physical properties and the basicity of amines. So okay, students. So we have to stop here. Bye, students.